Welcome back. We are discussing about the wastewater treatment. In this video, we'll be discussing about the septic tank, its purpose, construction, and the design of its sizing. Septic tank, as we can see, is a sedimentation tank of longer detention time where digestion and sludge also takes place. So it is a dual role, so taking a dual role here, sedimentation of the solids along with digestion of the solids. It is mainly used for treatment of household sewage. It is usually a two-compartment system with first compartment occupying two-third length. Now you can see two different pictures are there. In the bottom picture, you can clearly see there are two different compartments are there. The wastewater or sewage is now entering to a T-pipe side, so well below the top of the liquid level, so that water will enter here. And then what will happen? The solids, whatever are there, that will be settled down to the bottom in the form of sludge, and the lighter particles like oil and fat material will go to the top of the tank in the form of a scum, and thereby the scum is separated to the top, solids are separated to the bottom, and the water is liquid portion is there in the middle. So now we'll provide an outlet here in the partition at the middle, somewhere in the middle here, so that clear liquid will goes to second compartment. If final solids are still escaping, settling in the first compartment, they will be settled out in the second compartment as well, and clear water now takes out the tank through an outlet pipe. So here there's a small opening is provided in the partition wall, this model, and here we can have a inverted pipe we can introduce here well below the top scum layer, so that this liquid can easily go out. Both are same, but the option of providing the liquid moving from first compartment to second compartment is changed. And then we're having a manhole covers here at the top, so that you can go for inspection in order to clean. So you can take out the sludge for withdrawal at periodical intervals, and subsequently the septic tank can once again be put into operation. So the sewage enters the first compartment where sedimentation takes place. Solids will settle down as sludge. Clear water leaves the first compartment to second compartment and leaves out of septic tank. Liquid coming out of septic tank, is a cleared liquid, is sent into the nearby soil for absorption in natural methods. It should not be directly sent out. It should not be directly sent out. So there should be a proper disposal method for the sewage coming out. So we are providing some soil absorption systems. We will discuss that. The sludge settled in the first compartment and second compartment will undergo anaerobic decomposition, producing foul gases. That's why we are providing two vent pipes here, first compartment and second compartment. The liquid coming out of septic tank is having low DO because its anaerobic decomposition is happening. So the water coming out is having low DO and high BOD. So it should not be discharged into water bodies because it will quickly consume the dissolved oxygen in the water body and making it very unhygienic in the stream. So that's why we should not do that. It should be drained off in the nearby soil absorbing the liquid. Normally, the two systems which are provided for soil absorption are soak pits, either it can be lined or unlined, and dispersion trenches. Now, this is a line diagram. Once again, the sewage coming in, the sludge is separated to the bottom, scum layer is going to the top, clear liquid is there in between, is going out to second compartment where there are a clear liquid here. Now sewage goes out, the vent pipes are there, and parallelly you can provide manholes here so that people can enter for maintenance and inspection purposes. So now let us look at the design details. We are having a code book, IS code 2470, part 1, 1985. So some design parameters are mentioned. The depth required in the sedimentation tank for this septic tank is for sedimentation of the solids in the tank, and space required for the sludge storage, space required for sludge digestion, and freeboard. So this is the simple technique, the simple septic tank here. This is the sewage coming in and going out, and now you see here the opening is created in the partition wall between first compartment and second compartment. So the clear liquid will goes out. At the top, we are having the what we call the scum layer, and then the bottom you are having the sludge. So clear liquid comes out here. Now here we are keeping a manhole where people can go inside for access. This is outlet pipe. So detention time usually we keep for 24 to 48 hours. This will help in sedimentation of the solids. And the volume for sludge storage is empirically worked out as 7.3 meter cube per 100%. And volume for sludge digestion is 0.032 meter cube per capita. Freeboard is usually 30 centimeters. And keeping all these factors into consideration, the depth of the tank will be around 1.2 to 1.8 meters. The L/B ratio is usually 2 to 4, is a rectangular tank. Sludge withdrawal, it can be for 1 to 3 years. And the sedimentation zone, there are some requirements. Usually we calculate the total water coming into the house, and we take a factor for wastewater generation, and then calculate the sewage generated from the house and entering into septic tank. But as per the IS code, it says that the surface area required will be 0.92 meter square per every 10 LPM of peak flow rate, such that a minimum depth of 25 to 30 centimeter provided in the tank. And what is this peak flow? Peak flow is nothing but here, it is based on the number of plumbing fixtures discharging simultaneously. The plumbing fixtures means your wash basin and other taps, bathroom, uh, sinks, all these things put together, number of plumbing fixtures. If they are operated continuously, then how much water is expected to be generated in the house? That is how you are going to calculate. These details are given in the code book for reference. What type of fixtures are there? How much we can estimate the water coming out for how many fixtures or what percentage of operation in terms of LPM, everything is given there. And we can also find from the code that there are some standard sizes of septic tank based on the number of users. So length, breadth, depth, and the options are there. Depth of the tank, if you are withdrawing the sludge every 1 year, and if you are withdrawing the sludge after every 2 years. So the data is available in IS code for 50 users, 100, up to 300. So without any discussion, we can straight away use these dimensions if you are using keeping a septic tank in a locality of up to 300 users. Now we take a small example. Instead of taking the peak flow, we normally go for empirical estimation of the sewage generation for a septic tank. Design a septic tank for 500 persons contributing sewage of 150 LPCD. Sewage flow we calculate as 150 to 575,000 liters per day, which is equal to 75 meter cube per day. 75 meter cube per day. And detention time 24 to 48 hours. If we assume 24 hours, it is 1 day detention time. Volume of the tank is nothing but discharge multiplied by time. So 75 meter cube per day into 1 day is equal to 75 meter cube. And volume for sludge storage is given as 7.3 meter cube per every 100 persons. Here it is 500 persons. So put that ratio here, and then it comes out to be 36.5 meter cube. And volume for sludge digestion is 0.032 meter cube per capita. Here is 500 persons. So multiply with 500, you are going to get 16 meter cube. So the total volume is equal to 127.5 meter cube. This is we calculate for sedimentation, sludge storage, as well as sludge digestion. So let the depth of the tank between 1.2 to 1.8 consider as 1.5, and L by B ratio is if I take as 2, L by B ratio I take as 2 rectangular, and 2B square is equal to what? Volume by HA. So 86 meters square. So volume by H, depth is equal to area. Area is equal to L into B. When L is equal to B, it is equal to 2B square. So working out the dimensions, B is equal to 6.6 meters, L is equal to 13.2 meters, H is equal to 1.5 meters plus 0.3 meters of freeboard. This is simple calculations, not going into too much of details. Is usually adopted in a practical manner. And simple estimate of sewage generation, if you look at how we normally calculate as a thumb rule, so population say 1,000 population, and if you estimate the water demand in that region as 200 LBCD, the sewage flow will be expected around 75 to 80% of the water demand. So therefore, water flow is equal to 1,000 into 200, which is equal to 0.2 MLD or 200 meter cube per day. And 75% generation of this water is a sewage, if you assume, which is equals to 150 meter cube per day. So this is how, without any data or code book, we can calculate and then go for rough estimate of the sizing of septic tank. Thank you.